Hey, welcome to Math. Mr. Jorgens here. We're going to be going over section 4.6 for the second today. We're going to call it 4.6 on arithmetic sequences part 2. Make sure you're paying attention. There will be a few questions for you along the way. All right, let's take a look at a review problem that's similar to the ones we did yesterday, or in part 1 of the Ed puzzle for 4.6. We're going to find the common difference in the next three terms of the sequence 7, 10, 13, 16, and so on. So again, the common difference is the amount you'd have to add or subtract to get to the next value. So what do we have to do to get from 7 to 10? What would we have to do to get from 10 to 13, and so on? So common difference, we covered it yesterday. So find the common difference, D, and enter your answer when you're ready. So here, 7 plus 3 is 10, 10 plus 3 is 13, 13 plus 3 is 16, so our common difference is 3. Now that we have the common difference, I want to be able to find the next three numbers, or the next three terms in the sequence or the pattern. So go ahead and find those next three terms in the pattern and enter your answer when you're ready. All right, so 16 plus 3 would be 19, 19 plus 3 would be 22, and 22 plus 3 would make 25. Today we're going to kind of use a formula or learn a formula that's going to allow us to solve for a bigger numbered term. And so we're going to be extending what we did yesterday with this work with arithmetic sequences. But the questions today are going to be more like find the 12th term, or find the 15th term, or find the 90th term, rather than always just finding the next three terms or finding the common difference. But we'll need to use this thinking in order to solve the new problems today. All right, so example 1, we're going to find the 12th term of the sequence 5, 7, 9, 11, and so on. Make sure you follow along with this example because I'm going to kind of step out how you would do it. Now, one way we could find the 12th term is just to actually go and find it, right? We have the first four, and we could just say 13, 15. We're counting by twos, right? 17, that's 7. 19, 21, 23, that's 10. 25, and 27, that would be 12, right? So one way it would be the long way of doing it, where you just do it out by hand, and our answer to this problem should be 27. However, if they asked you for the 112th term or the 1000th term, taking out terms by hand like that is just going to take too long. So we need to have a shortcut in order to do it faster. Now, what we can kind of think of is what we really did here is we started with 5, and we added 2 a bunch of times. So to get to the second term, I added 2 one time, right? To get to the third term, I had to add 2 twice. To get to the fourth term, I have to add 2 3 times, right? So to get to the 12th term, I had to add 2 11 times. Or we could just say 2 times 11 is the amount that we're adding. So 2 times 11 is 22. 5 plus 22 makes 27. Now, what that formula really is I can start with my first term. And we learned yesterday that our notation for the first term is A1. And then what I can add in is 2, which is the common difference, D, times n minus 1, because n is the number of terms, so n would be 12 here. And the number of times I have to add 2 in is always going to be 1 less than n, right? If I'm going for the third term, I have to add 2 twice. So 1 less, so I can times that by n minus 1. So if I wanted to find the nth term, in this case the 12th term, so an, meaning the nth term, what I can do is I can take the first term, and then I can add in the common difference times n minus 1. So this is kind of our formula in general. An, meaning the nth term, is equal to A1, which is our first term, times our common difference, and then number of terms minus 1. So that's kind of our formula here. We're going to be working with this formula throughout the day today. All right, example 2. This is the first one where we're going to find a bigger number of terms. We're going to find the 71st term of the pattern 6, 10, 14, 18, and so on. Now, again, 71st term is going to, I could find 22 and so on, 26, but that's going to take too long, right? And so if I'm going to find the 71st term, the kind of faster way of doing that is by using my formula here. AN equals A1 plus our common difference times n minus 1. Now, I have some things I can plug in here. I need to know what my first term is, what my common difference is, and what n is. In this case, I know that my first term is 6. And n is going to be 71, because that's the number of term I'm finding. So my first term is 6, the number of terms is 71. And then my common difference, in this problem, what would my common difference be? Enter your answer when you're ready. Yeah, so my common difference, I'm adding 4 to get to the next term. 6 plus 4, 10 plus 4, 14 plus 4, and so on. So my common difference would be 4. So now that I have these three values, I should be able to plug them into the formula here and solve it out for my nth term, right? So an should be equal to 6 plus 4 times 71 minus 1. So go ahead and work that out, solve out the right-hand side for the 71st term, and enter your answer when you're ready. All right, so working out PEMDAS here, 71 minus 1 is 70, starting with the parentheses step, and then multiply before adding. So 4 times 70 makes 280, and 280 plus 6 makes 286. So again, it would have taken a pretty long time for us to carry that pattern all the way out 71 terms. But in this case, I can kind of take a shortcut by just realizing I'm going to add in 4 70 times, multiply that out, and then add it to the 6. We got one more today for you to try. It's going to be very similar to this process, so make sure you understand this before you move on to the next one. All right, let's find the 101st term of the sequence -5, 0, 5, 10, 15, and so on. I'm going to write down your formula for you. an, the nth term, is going to be equal to a1, the first term, plus the common difference times n minus 1. That's the formula we're working with today. I want you to pull out your first term, your common difference, and your n from the problem. Enter in the numbers, solve it out, and enter the answer when you're ready. All right, so you can take a look and check your work here. Again, my first term is -5. My common difference, I for some reason wrote D there, but my common difference is 5, right? So my common difference should be 5. We have the 101st term. Plug in the values, and again, we want to add in 5 100 times to get to the 101st term. So 5 times 100 makes 500. Add that 500 to the first term of -5, and you get 495. So this was kind of where the section built up to. Again, on the big ideas problems, a lot of it will be some of the easier stuff from the first day. You're now ready to try the big ideas problems for 4.6. So go ahead and take a look at those. And if you have any questions on that, make sure you reach out and ask. Hope you had a good day, and I'll see you soon.